So the last couple of days, we've talked about the law of sines and law of cosine. There's a quiz out there for you. It's labeled Quiz 59 on oblique triangles. That'll be about the law of sines and cosines. On the fourth problem, last problem, I believe there's one side that I think it's labeled, it looks like it's labeled 18 degrees. Just be aware of that. And that is an obtuse triangle. If I remember right. That one's supposed to be obtuse. I can double check quick, actually, since I'm right here. I know there's one of them that was obtuse that people kept missing. All right, so yeah, I rechanged it so that the obtuse angle is labeled there. Okay. So what I want to do today, I want to do a couple of things. I actually want to show you a third trig formula like the law of sines and law of cosines, and do just a brief example of how it would be used. Then go back and review law of sines and cosines. Remember, tomorrow is our unit test. So I will be logged into class at the beginning, just in case anybody has any questions. If nobody's here in the first 10 minutes, I'll probably take off. But all you have to do tomorrow is just take the test. Nothing else. Go home tonight and finish the test. You're good for tomorrow. You can sleep in an hour. So we have law of sines, law of cosines. What about law of tangents? There actually is a law of tangents. It is not nearly as simple as law of sines and law of cosines. The law of sines is fairly simple, it's just the ratio. The law of cosines is a little bit longer formula to memorize. But if you remember the idea of the generalized Pythagorean theorem, it's not so bad. You just have to memorize that correction term. Law of tangents, I think, is a lot more difficult. So if we have sides A and B and angles law of tangents tells us that length of side A minus the length of side B over side A plus the length of side B. So that ratio of the difference of the sides to the sum of the sides will be the same as the ratio of the tangents A minus B over 2. A plus B over 2. Now the strongest use of this set of ratio, this proportion actually, is to verify that a triangle is correct. Now, anybody can draw a triangle up there, label the angles, and label the sides. Well, it might not really be a triangle. But you could also use the law of sines to verify. The law of sines doesn't give you equal. The biggest thing here is it gives you two pieces at once. Other use that it can be used for we have a triangle, it looks something like this. We'll call this A, B, and C. We know that this angle C, is 58 degrees. And we know that side A over here is 60 millimeters. Side B is 49 millimeters. You can rearrange this formula here. So so that it looks like this. I keep the tangent a minus b over 2. And we're going to multiply by the tangent of a plus b over 2. The other side, we still have the sides, a minus b over a plus b times the tangent plus b over 2. Now I want to take a peek at this little piece right here, a plus b over 2. What's a plus b plus c have to add up to? The three angles of a triangle add up. 180 degrees. We know those three angles have to add up to 180 degrees. Well, a plus b over 2. If I add that to c over 2, what does that have to add up to? I did everything by 2, so that means 90. If they add up to 90, that means they're complements, right? So if they're complements, I can replace the a plus b over 2 with c over 2. I'm going to stay tangent a minus b over 2 equals side a minus side b over side a plus side b times, instead of tangent, I can do the cotangent of the complement. It'll be the cotangent over 2. So that means is for this triangle here now, I can set up that formula. Tangent SB is equal to 60 minus 49 over plus 49 times cotangent now I can do a lot of calculating here. First of all, this piece right here, well, 60 minus 49 is 11, plus 49 is 109. Cotangent of 58 over 2, well, that's cotangent of 29, right? We'll do cotangent of 29. I do tangent of 29, and then I do the reciprocal outside the parentheses. So 1.1272. I'm going to multiply this whole mess together over here, the 11 over 109. Notice I'm going to leave that 1.127 in my calculator. I'm just going to multiply by 11 divided by 109. Gives me 0.1138. Again, I'm leaving that in my calculator. I'm not clearing it out. Tangent of a minus b over 2 equals that. So my next step is going to be to do again, keeping it in my calculator, I do second tangent, second answer. Get so let me go back and redo that cotangent because I'm sure that's incorrect. 1 point. Tangent of 29 and reciprocal outside. I'll change it to 1.804. And then times the 11 divided by 109 changes it to 0.1821. Now I have to do the inverse tangent of that. Second tangent, second. 10.32 degrees. So that erases the tangent over here. I have a minus b all over 2 equals 10.32. So I'm going to multiply by 2 on both sides. Gives me that a minus b equals 20.64. How does that help me with anything? Well, because I know that a plus b plus c 180, and I know that c 58 by subtracting that 58 from both sides. I know that a plus b has to be 122 degrees. A minus b has to be 20.64 degrees. I have a system of equations there. I'll add equation 1 to equation 2. These are actually set up to do elimination rather quickly. A plus a is 2a. B plus negative b cancels out. That's 0. 122 plus the 20.64 is 142.4. I can divide by 2 to find A. A is 71.32 degrees. If I subtract that from 122, I can find B. What I did was I found, in this triangle up here, found angles A and B without ever having to find side C. The question is, why do we need that? There's no reason why we would not be able to just use the law of cosines to find C, then use law of sines to find A and B from there. Law of tangents is a nice, cool little rule. It's just not practical. Because the only way to really apply law of tangents to find missing parts is like we did here, using a system of equations. Well, if we don't have to use a system of equations, why would we want to? The only real use for law of tangents, like I said, is to verify that the parts of the triangle are correct. Even then, there's still easier ways to do it. But I wanted to show you that there is a law of tangents out there. We've got law of sines, law of cosines, there's law of tangents. Law of secants is actually, there is a law of secants, but it's not a trig related law. Law of secants secants relates to is a circle. You have two secant lines like this. I tell you that this piece is 8 inches long. Seven inches long. I want to find that piece. I'm going to come back and I'm going to relabel these pieces A, B. Law of secant says is B times A plus B has to equal D times very similar to our law of chords that we had. And I can remember that. We had intersecting chords within a circle. 4 and 9. This piece was 3. This had to be 12. because the two pieces of each chord had to multiply the same number. 3 times 12, 36. 4 times 9 is also 36. So it's very similar. So here we just put in the numbers. B is 8, A is 6, 7, C is X, and D is 7. And we could just solve this equation. 8 times 14 is 112. Over here we've got 7x plus 49. Subtracting 49. Law of secants is actually, even though we didn't learn it, it's one that I've always wondered why no textbooks, all the textbooks, they have this rule of chords in there, but most textbooks you see don't put a lot of secants in there. In machining, there actually are some applications where that's handy. Because we have so much work with circles, we tend to focus on the tangents. We have the tangents out here. Because they are more useful, those tangents form those right angles. That's how we can split up a V block or whatever. But that secant rule does come into effect quite often. So anyway, let's take a peek at some of the more difficult examples that might appear on a test, quiz, or other application. Rather than drawing out the triangle here at first, I'm just going to give you the information. I have angles, capital A, capital B, capital C, sides, little a, little b, little c. If I tell you that angle A, 33 degrees, and that side A is 27 millimeters, and that side B, 31 millimeters. Anybody recognize potential issue? Given two sides and an angle. When we are given two sides and an angle, what should we check for? Does anybody remember? Side opposite the given angle. What are we looking for in that side? (27) is the side opposite the given angle, 33. Quarter of the two sides, right? Because that's the shorter of the two sides, that means either there's two potential triangles here, or it might not even form a triangle at all. If it doesn't form a triangle at all, it'll show up really quickly because the sine will be bigger than 1. That won't be an issue. But there's still, even if it is long enough, it does make a triangle, there will be two potential triangles here. One will have A as, or B here as an acute angle, the other would have B as an obtuse angle. So we need to be given that information. We either need to have a picture that shows it clearly obtuse, or we need to be told whether it's acute or obtuse. I'm going to tell you here that B is obtuse. When I set up my law of sines, I have my 27 millimeters over sine of what? 33 would be the opposite angle, yep. Equals 41 millimeters over sine of, now we are going to cross multiply and divide to find the sine of B. We have sine of 33, make sure you close that parentheses. Make sure you get both 3's in there. times 41 divided by 27. Gives us 0.8270 for sine of B. So then, of course, next we have to do I just keep it in the calculator, second sine, second answer. 55.80 degrees for B. 5.8 degrees? No, why not? Deuce. How do I find the actual angle for B? That's going to be 124.20. Which will leave us, if we add them up and subtract from 180, angle C then has to be 22.8. I'm going to trust you guys can find side C. If I tell you that angle A side B is 27 millimeters, side C is 40. Can I use the law of sines here? What must I have to do law of sines? I must have a side and the opposite angle. Do I have that here? No. The only angle I have is 52 degrees. The opposite side would be A. I do not have that. So that means I have to use cosine. Log cosines. Now, normally log cosines is designed around finding side C if you're given angle C. But here we're not given angle C, we're given angle A. So I'll write out my formula here. The normal formula is C squared equals A squared plus B squared minus 2AB. But because we're not given C, we're given A instead. Everywhere I see C, I'm going to put in an A. Everywhere I see A, I'm going to put in a C. Change those pieces out. It would be A squared instead of C squared. Equals, well, instead of A squared, the C is going to go there, so C squared. Plus B squared minus 2AB is going to be 2 times C times B. Times the cosine, instead of angle C, it'll be angle A now. Now I can put in those numbers. Squared will be 46 squared. B squared will be 27 squared. Minus 2 times C is 46. 7 times the cosine of A is 50. Now we mentioned yesterday, when you put this in the calculator, that whole right side needs to go in as one piece. Because if you hit equals during that process, 4 out of 5 spots that you would hit equals would up your answer. So we're going to do 46 squared, 7 squared, minus 7 times cosine degrees. 1350.09. Now that is A squared. And A we still have. 36.74 we get. So we can set up law of sines now at 36.75 or 74 millimeters, sine of 52 degrees. Which side do we want to use for the other one? Do we want to use the 27 or the 46? 27. Always use the smaller side. That's going to be over the sine of which angle? Cross multiply and divide to find the sine of B. Divided by 36 points. Sine of B is 0.5869. We'll do an inverse sine to get B. 35.94. Now, is found simply by adding these up. 91.06. The issue there, if we had used the 46 first, if we'd used the 46 first, we would have got 88.94. Even if there was a picture, how do you tell the difference between 88.94 and 91.06? Not going to. That's why it's very, very important that when you use that law of sines, you always use the smaller side first. Let's look at this one. Obviously not on the scale. I'm going to find angle C here. And remember, we rearranged our law of cosines. We have all three sides, we can use it to find the missing angle. A squared minus A squared minus B squared for negative 2AB. Cosine of angle C. That look familiar? So, is 78 squared, minus A is 42 squared, minus B is going to be 49 squared. All over a negative 2 times A is 42 and B is 49. So here again, I'm going to do everything on top first. I'm going to do 78 squared minus 42 squared minus 49 squared. 1919. On bottom, negative 2 times 42 times negative 4116. Now I don't need to actually divide out that ratio, that 1919 over negative 4116. I just need to do the inverse cosine. Right in the. Now here I do have to make sure I enter the negative because only one of them is negative. Inverse cosine gives me 117.79 degrees. Well, the nice things about cosines is cosines do give you obtuse angles. The angle that would have the same cosine would be a negative angle, so it's never going to come up in triangle. Of course, now that we have that angle, we can use law of sines to find the other angles. I'm going to trust that you guys can. So, your packet, page 385. Review. Just review some of the applications of law of sines. So remember, tomorrow is the test. Again, I'll log into class in case anybody has questions on the test, but as long as you get the test done, you don't need to log in. And also a reminder, Monday, I am taking personal. We'll let you guys have the rest of the time here to start on stuff. Bye, you guys have